Board meeting. Okay? You've had all your boards done. We have a board meeting. Now, here's the way it works. I want everybody to pick up the papers and their board, and let's get a circle so everybody can see everybody else's. Now, I'm going to tell you, in my classroom, it's a no-hate zone. And by that, I mean, I don't care if their answer is completely ridiculous, because the objective is to get the ridiculous out of there by the time we're finished discussing it. Does that make sense to everybody? So, let's get ourselves up, get their energy going, and let's see if we can form a circle where we see everybody else's. I'm going to tell you, the very first question, we got a lot of different answers on. Well, there's only two answers.
Oh, they gave
There you go.
Are you going to...
Oh, I'm fine. That's why I'm not on there.
Alright, everybody see everybody. Alright, now, I've got groups with different answers on here. Okay? And I've got some with a couple of answers. Okay? Yeah, no question marks. You got to put both answers. But what we're going to do, I like the way this is done, where you're circling agree or disagree. Why would that be good? It's a little more obvious to everybody what's actually happening. Because some of you picked yes, no, false, true, or combinations thereof. Okay? And that's okay. It doesn't matter really, does it? Okay? So, let's take a look at the first one. First one, if there's motion, then a force is acting. How many boards in here have agree? Raise your hand with your group if you have agree. Okay. How many people have disagree or no or false or something along that line? So we split just about half, didn't we? Pretty close to half. Now, what I would tell my class is, you've got 2 minutes to come up with the right answer. And if not, I don't know what I do. Okay? So, what we need is a little discussion. But let's start off this way. I had two groups that did diagrams of A and B. Okay? We have one right here, and which other group did A and B? Okay? Let's put these illustrations side by side for a minute. Okay? Let's bring them right up here if you could, or actually, let's bring them over on this side. And if y'all would explain yours. What's kind of neat is that you both have different answers. What I'm going to ask you to do is to explain your drawing and defend your answer.
Okay, we drew a table with the water bottle on it. We felt that there were forces acting right here, but there was no movement. That the push of the table up and the pull of gravity down, that it was a zero net balance force, but that there were forces acting. And so we thought that there did not have to be motion to make sure that we thought that it was the law of inertia.
So this is B.
That was B. Yeah.
Oh, I'm sorry.
But for A, it's once you put an object in motion, it can still move because of inertia, but inertia isn't a force. So that's why we said that an object can still be moving without a force.
So you disagree with that?
We disagree with A because we say once you put it in motion, it can stay in motion without a force.
Okay, can you explain yours here?
We illustrated the cart process that we went through at the last workshop. And the dialogue that we had a lot more to do with, if you have some math background, if A, then B. And so the way that the question exactly is worded, it says if there is motion, then there must be force. And that has,
then a force is acting.
Right, but there must be. Objects are set in motion by some sort of force, whether it be gravity, it's got to happen. So exactly the way that it's written, we had to agree. Although we did discuss very similar to what you all had talked about. And we even talked about if there's a force, then there's motion. We decided that that's not necessarily true. We would disagree with that. So the way exactly it's written on the paper, we had to agree.
I got a comment. If you want to go with the way it's written, the force is acting. You could say a force has acted, but at this moment, if it's not accelerating in any direction, it's not acting anymore.
You know, in November, we're going to put into flight another mission to Mars. We're going to put a satellite, not a satellite, but a lander on Mars. And one of the things we do is we'll fire a rocket up, get it away from the gravitational pull of the Earth as far as we can. And in between the Earth and Mars, it doesn't fire. Okay? How many forces are acting on it exactly between the gravitational fields of Mars and Earth? Ignore the Sun and other planets right now. How many forces would be acting on it? There wouldn't be any, would there? There wouldn't be any forces, right? They'd be evened out, wouldn't they? Okay? Now, the question is, does that craft keep moving? I hope so, otherwise we've wasted $1 billion, haven't we? Okay? So, while it's moving, and this goes to interpretations that you guys are good to point out, while it's moving, how many forces between Mars and Earth are acting on it? In terms of its motion, it's got forces acting on it, but in terms of its motion, there's not much there, is there? Okay? Does it need a force to act on it while it's moving? Now, what causes me to walk?
You're pushing off on the floor, and the floor is pushing off on you.
Okay? I've got forces in order to do that. What would happen if all of the force from the floor stopped on me? In other words, if I was on an icy surface that had absolutely no friction.
Good luck.
Good luck, right? Okay? Anybody who slipped in ice, you felt that, haven't you? Okay? And, you know, my dog at home, when she's running along on her wooden floor, it looks like there's no force acting on it. Okay? In order to keep moving, do you need a force? That's the question here, I guess. Okay? Now, one thing we're going to find, not all these questions are necessarily great in their wording. Okay? And we've seen EOCs, haven't we? Okay? Same thing there. Okay? So, what I want you to do, and I'm very serious on this, is I want you to think about what the one answer you would like for this big group here, which is sort of like a big classroom, to have. What would be the best answer? How many people in here say agree? How many people say disagree? How many people say where's lunch? Right. So are we agreeing on it? We disagree.
Are we agreeing on we disagree? Is that what you...
Okay, are we agreeing or disagreeing? We're disagreeing. Okay? And we're only going to go through 3 or 4 of these and go on to the next one, because you can see where this takes a long time, doesn't it? Okay?
So, in getting back to what we talked about in the past few sessions, the law that's important here, right, is that is Newton's first law, right? An object that's in motion tends to stay in motion. An object at rest tends to stay at rest. And something that was said over here is important. This is another kind of idea that we struggled with in the first session. This idea of inertia. Inertia is not a force. Inertia is the tendency of something to keep moving. And so that's really what this question is getting at. All right, so the second question's pretty... Charlie, you want to go through the first 3?
I'll tell you what. Why don't we skip down and go to C?
All right.
Who had the pictures of C? Who had the pictures of C and D? Okay? Let's juxtapose you. Put you side by side. Okay? But I need these out here so everybody can see them. Would you mind explaining yours? Your drawing?
So the statement is there cannot be a force without motion. So we do a wall and someone exerting a force on the wall. Unless they're Superman, the wall's not going to move, so there's still a force. So we disagreed with C.
Yeah, we
And what did y'all have?
Pushing on the box.
Just pushing at the same time and not moving.
Force with no motion.
Okay, over here though, we have agree. You guys have disagree, right?
Yeah.
I have agree here. I have disagree here. Disagree. 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 This is there cannot be a force without motion.
It was a weird. Yeah.
I think as much as anything else, we're starting to see how questions can be important.
Yeah.
Okay, that's part of that wasn't part of the original purpose, but it's a pretty good statement on this, isn't it?
We were hoping it was the same as B.
B and C are the same question.
Okay, go on.
That's what we said was another way to word it.
But if there is no motion, then there is no force acting.
That's the way we took it. We were hoping that.
Yeah, I agree. One thing I'm going to tell you as I look through these, if you get textbooks that have questions with them, a lot of times you run into this, don't you? Now, how would you handle this if a student came up with the same two ways of looking at it as you did? How would you explain that? Well, you've got a good basis of idea of physics behind it now, don't you? Which law are we dealing with here? Okay. Could be. You could actually qualify it as first or second, couldn't you?
Or even third.
Or even third.
You know, equal and opposite. I mean, what you're saying, I think what both of these drawings are, you're showing forces and balance. And there's no motion with forces and balance.
Let's do F. F I like.
Yeah.
Okay, who had F to draw? You did? Okay, anybody else just want to group on that? All right, we got the artist here. Okay, I got disagree here, got smudge here, disagree, disagree.